All right. I had a conversation with a physics PhD this morning. He's much smarter than me, but we were talking about this book, The Joy of Abstraction. And he told me that this book, which I have right here, is the most complex mathematics that we know about. And there's really nothing outside of this book. This has all the math it has. It's about category theory, which is a subset of mathematics that is the most advanced mathematics we know of. That beyond that, there's nothing. And he suggested that I start this channel. He said that I should start up a YouTube channel to just talk about this book and kind of what I find out of it, where it meets me in my life. So that's what I'm doing. What I like about this book is it's written at the understanding level of a layperson. I'm going to try to remember as much of the conversation that me and this physics PhD, I think his name is Samrat, or Smrat. I terrible with names sometimes, but I believe that was his name. I'm going to try to remember as much of our conversation as possible to include that in here, because, I mean, he knows way more about this than I do, to be frank. But he said even he said he knows 50% of what's in this book. He knows half of it, which I think is pretty bold claim, but that's what he said he knows. Well, we started talking about it. There's, I can show you some of this here. This is a book published by Cambridge University Press. I don't have full access on here, so I can't show all of it to you, which is a bummer. But if let me get rid of all this other stuff. Don't want to show you my bank. That can't do live stream yet. We're waiting 24 hours. Okay. I think if I go back, we got some table of contents, and it's kind of messed up how it shows us this. It doesn't show us everything. But where we started talking about this book was with context. Context is a really big issue with large language models. They're limited in the scope of what they can discuss with us by context. A lot of people might be familiar with that term context from prompting, because OpenAI a while back recommended that when you're prompting, you refer to information that you add in the context of the triple quotes delimited below. So basically what OpenAI was saying is you can copy paste context that you know is correct for your conversation, and you can clue the large language model into that context by just telling it, hey, I gave you this section, this paragraph, and I want you to have this conversation within the context of what I just shared with you. And from there, it was really a leaping off point where we talked about Einstein and how many people say Einstein wasn't very good at math. He needed help doing not the arithmetic, but basically working out the mathematic part, the actual calculations of his theories with general and special relativity. He relied on another person who was brilliant at mathematics to help him with that. One person was his first wife, who oddly enough was his first cousin. That was an accepted thing in the day, although today I don't want to call him a pariah, but people look at that and they say, oh my gosh, that was just wrong. He married his cousin. But she helped him with a lot of the calculations in the mathematics. And then later, I believe it was a physicist, I want to say he was a Russian physicist, helped him as well. And what Samrat was saying is that Einstein was bad at math in the sense that math in the real world, like let's say if you're in an academic setting, they put you in a room and they set a timer for, say, 2 hours, and they say, solve this math problem. And that's all you get. And Einstein couldn't do that. He was a brilliant mathematician, but he was limited by this time window, almost like this concept of context, where he didn't have enough time, he didn't have enough context window to solve the math calculation part of his thought experiments, which is very similar to large language models because there's a context size limit. So that's where your bottleneck is with large language models, is you're kind of limited to that scope of that. The analogy here is that you've got, say, a 2-hour window to have this conversation. It's not exact, but we're just trying to relate this to the metaphor of how Einstein was with math. Now, what Samrat told me is where Einstein was a brilliant mathematician is he assumed that he knew nothing and he had incredible tenacity. So he removed the context window for himself. Because really tenacity, well, let's not guess. Let's see the actual definition of tenacity. Okay. I don't always like to rely on these AI overviews, but sometimes they're right, especially when it's something that is pretty obvious. We can go to the dictionary too, but this looks right. The quality of being persistent, determined, and not giving up easily, showing a strong grip on a goal or idea despite difficulties. And I can already see what it's leaving out here is kind of it's the not giving up over time window. So tenacity can be over a short term period for sure. Like if you're a power lifter or an Olympic lifter, are you going to give up against that incredible force and that compressed time window, that compressed context? But in the conversation about Einstein's tenacity, it was over the longer term. He expanded his context, and he spent many, many years working at the mathematics behind his problems. So that's why Einstein was actually brilliant at math, even though people say he wasn't. He had incredible tenacity. And I'm already forgetting the rest of the conversation here, or where I should go from this point. So I guess I'll back up a little bit. It's part of category theory is zooming in and zooming out, which can allow you to, it can bring you back to your frame of reference. There's a lot that can do for you. Let's see what this book actually says. Maybe I can get a little bit of it in here. So each of these, the way this book is broken up, if I can get the whole page in here, you can see zooming in, zooming out starts right here, and the end of it starts right here. So it's like little chunks. It gives you little context windows. Kind of, you could use this for yourself or with a large language model. I wish I could, let's see if I can bring up this actual page. Probably not. I got to get access to this to share with you guys more. That's all I got for it. But I would read this whole thing, but we're limited by that context. I can't take forever to read everything to you guys. But it says, one of the powerful aspects of category theory's level of abstraction is that it enables us to zoom in and out and look at large and small scale mathematical structures in a similar light. And that, to jump around here, can help you to see the sameness in an equation, which is different from equality, but it's similar. It's very similar. Equality in math is a bit contradictory. You can see this very small equation here. 1 plus 5 equals 1 plus 5, but they're mirror images of each other. And those are, of course, that's an equality, right? Because each side of the equation equals 6, and we all know that. But it's not the same because the images are mirrored. The sides of the equations they're mirror images. So when we talk about sameness, we're not saying that the two sides of the equation are actually completely the same, or equality. We're not saying in math that the two sides of the equation are entirely the same. We're saying that they're a bit different, but mathematically they're equal. And to bring it back to what this book is saying in the context about sameness, is one of the main principles and aims of category theories is to have a more nuanced ways of describing sameness, right? Because it's equality, but not really. It's the same, but not really. Which brings us to the next part of the conversation that I had with Samrat. We were talking about him and his story. And she shared a story with me about how he was trying to get a job outside of academia because here at UCSD, he's a PhD student and he works at UCSD teaching other people that, he's a very prestigious position. He's from India. They chose him to come here because he's brilliant. But from a monetary standpoint, the compensation is pretty low. It's like 67 grand, which is good in most places. But in the context of La Jolla, which is the area we're at, that's not even a living wage. It can be if you're renting a room, but most people don't want to rent just a room. They want their own place. He has a child that he needs to provide for. So he was trying to get into another opportunity to earn more money. I can't recall the exact name of the firm, but he got an interview at a company that deals with predictive analytics with investments, which is big money, lots of money, right? And they were going to offer him to start $250,000 a year. And he would work in Philadelphia, which is more than a living wage. It's great. But he failed because even though he's a brilliant physicist, he's a brilliant mathematician, he knows half of the most advanced mathematics that we're aware of. Despite all of that, because he has some language barriers, because his native tongue is not English, he struggled to tell his life story, which that's what an interviewer wants to hear a lot of times. It's like half of it, right? So they said, you've got the math. We believe that. But you don't have a GitHub account. We haven't seen that you've written machine learning. We don't really understand how you got to the point that you're at. You're not really able to communicate with us in the languages that we're expecting. We're expecting you to sit here and be fluent. And he can't do that yet because he hasn't had enough practice. What they were asking him for was outside of his context window. So they didn't offer him the job. They gave it to somebody else. And he's staying in academia for now, which is okay. Because he knows that, he's in the right place. He'll get there when it's the right time. Which we continue on with the characterizing things by the roles they play. All right. Category theory seeks to characterize things by the role they play in context rather than by some intrinsic characteristic. And one of the advantages of characterizing things by the role they play in context is that you can then make comparisons across different contexts by finding things that play analogous roles in other contexts. And that's the key piece that he's missing right now, is that ability to bridge context, to be able to place himself in contexts that he's not really a part of yet. And this book goes on to say that, we're just talking about sameness and context, and this might sound like the opposite of what they just described, as it sounds a bit like properties that are universal regardless of context, but it actually refers to the property. What it actually is referring to is the property of being somehow extreme or canonical within a context. So what makes Samrat different within that context? The opposite of sameness, the opposite of equality. How does he stand out? What's his story? How does his story put himself in different contexts where he seems to not really, that's not his place, but it is, because he has this unique property that belongs in different sets that he's actually not a part of. And that's his story. That's what he needs to tell, and he can't do it yet. He just has to have the tenacity to keep going and practice, get the reps in of talking in front of people and explaining his story in English, and maybe explaining his ability to write mathematics solutions on GitHub in machine learning. Because the roles that things play can tell us something about the context itself. It says this can tell us something about the objects with that property, because it can tell us something about the context itself. And the example here is it gives is if we go around looking at the highest and lowest paid employees in different companies, so how they're different, how they fall into different categories, different contexts, that tells us something about those companies, not just about the employees. It is only one piece of information as opposed to a whole distribution of salaries across the company, but it still tells us something about the broader context. So that's that was the bulk of the conversation that we were having, because we were talking a lot about him and where he's at and how he can get to where he's trying to go. I think I'm going to, pause and leave things off at that point, because, man, the conversation went from there got into religion, and he told me that he can prove with set theory to an atheist that religion is true. And this is all, pretty spiritual stuff. Maybe not everybody believes in that stuff, and that's all right. But I think that we've had a pretty good talk so far about this book. It covers the most advanced mathematics that we know. There's no math beyond this. There's no math beyond this. This is it. It's written at the level of a layperson. It's Cambridge University Press, written by Eugenia Chang. She also wrote How to Bake Pie. This is an exploration of math, category theory, and life. It was only written in 2023. I once read a book by Nassim Nicholas Taleb, and he said only read books that are over 10 years old, that have been reprinted, because they're proven. I'd say you should take a chance on this, even though it's only 2 years old. I think you'll find it worth it. You can see here it has some cool graphs and charts. It shows, it's bringing us in at this most advanced point in mathematics, the opposite of what people usually think, where you usually think you should start. But sometimes that top-down approach can really help. It has all kinds of cool charts about how this category of mathematics is related to the other types of mathematics, the other categories, those other contexts. And it also shows how you get to it. you start at mathematical thought, and that leads to category theory, and there's all these other branches. Most of the time we start by teaching somebody the times tables, 12 times 12 equals 144, that kind of thing, and then arithmetic, and then algebra and geometry, and then calculus, and then category theory might lead to more mathematical thinking and to group theory and topology. But what this book is saying is that the traditional methods aren't right for everybody. That sometimes it's better to start at this more advanced level, and it can be more helpful for you. Look at this. Category theory sits right in the middle of all these different disciplines. Engineering, chemistry, biology, theoretical physics, pure math, computer science, systems thinking, social justice, linguistics. And it shows you a little bit about the content of this book in this graph here, this chart, infographic. This covers finance, applied math, systems or systems thinking, biology, chemistry, engineering, theoretical physics, pure math, computer science. It's all part of category theory. It's all part of this book, The Joy of Abstraction. It goes over the audience here, but I would say if you've listened this far, you've watched this far, you should give this book a shot. The Joy of Abstraction. An exploration of math, category theory, and life by Eugenia Chang. All right, I'll leave it off here. See you next time.